Jupiter is the largest planet in our solar system, and its physical characteristics have fascinated astronomers for centuries. Known as a gas giant, Jupiter's immense size, dynamic atmosphere, and complex magnetosphere make it a standout planet in many ways. Below is a comprehensive exploration of Jupiter's physical features, including its size, composition, atmosphere, magnetosphere, and internal structure. Jupiter is the largest planet in the solar system, with an equatorial diameter of approximately 142,984 kilometers, 88,846 miles. This makes it over 11 times wider than Earth. Its polar diameter is slightly less, at about 133,709 kilometers, 83,082 miles, due to its rapid rotation, which causes it to bulge at the equator and flatten at the poles. This phenomenon, known as oblateness, gives Jupiter an oblate spheroid shape rather than a perfect sphere. Jupiter's mass is 1.898 times 10 to the power of 27 kilograms, which is about 318 times that of Earth and more than twice the mass of all other planets in the solar system combined. Jupiter's volume is so vast that it could hold more than 1,300 Earths. Despite its enormous size, it has a relatively low density of 1.33 grams per cubic centimeter, much lower than Earth's density of 5.52 grams per cubic centimeter. This low density reflects its composition, which is dominated by light elements like hydrogen and helium. Jupiter is primarily composed of hydrogen, about 90% by volume, and helium, about 10% by volume, making it similar in composition to the Sun. Trace amounts of other elements and compounds, such as methane, ammonia, water vapor, and hydrogen sulfide, are also present in its atmosphere. These trace substances contribute to the planet's vivid colors and complex atmospheric chemistry. Beneath the atmosphere, Jupiter's composition transitions into a layer of metallic hydrogen. This exotic form of hydrogen exists under the extreme pressures and temperatures found in Jupiter's interior. Below the metallic hydrogen layer lies a core, which is believed to be composed of heavier elements such as rock and metal, although its exact composition and size remain subjects of scientific investigation.
Jupiter's atmosphere is one of its most striking features, characterized by its dynamic weather patterns, colorful bands, and powerful storms. Jupiter's atmosphere is divided into several layers of clouds. The uppermost layer consists of ammonia ice clouds, while deeper layers contain ammonium hydrosulfide clouds and water ice clouds. These cloud layers are organized into belts and zones that encircle the planet. The darker belts and lighter zones are regions of alternating high and low pressure, with the belts representing areas of descending air and the zones areas of rising air. These patterns are driven by Jupiter's rapid rotation and internal heat. One of the most iconic features of Jupiter's atmosphere is the Great Red Spot, a massive anticyclonic storm that has been observed for at least 400 years. The storm is approximately 16,350 kilometers wide, large enough to engulf Earth. Its reddish hue is thought to be caused by chemical reactions involving trace elements in the atmosphere, though the exact mechanism remains uncertain. The Great Red Spot's longevity and energy source continue to be topics of active research. Jupiter's atmosphere is incredibly dynamic, with winds reaching speeds of up to 618 kilometers per hour. These winds are strongest at the boundaries between the belts and zones. The planet also experiences frequent storms, including small, short-lived white ovals and larger, long-lasting storms. Lightning has been observed in Jupiter's atmosphere, indicating the presence of convective activity similar to thunderstorms on Earth.
Jupiter's magnetosphere is the largest and most powerful in the solar system. It extends up to 7 million kilometers toward the Sun and stretches beyond Saturn's orbit on the night side. Jupiter's magnetic field is generated by the dynamo effect, which occurs in the layer of metallic hydrogen within its interior. The field is about 20,000 times stronger than Earth's and is tilted by about 10 degrees relative to the planet's rotational axis. This tilt causes the magnetic field to wobble as the planet rotates. The magnetosphere traps charged particles, creating intense radiation belts around the planet. These belts pose significant challenges for spacecraft, as the radiation can damage electronics and instruments. The radiation is particularly intense near Io, one of Jupiter's moons, which contributes material to the magnetosphere through volcanic activity. Jupiter's magnetic field interacts with the solar wind to produce spectacular auroras near its poles. Unlike Earth's auroras, which are primarily caused by solar wind particles, Jupiter's auroras are also influenced by particles from its moons, especially Io. These auroras are among the brightest in the solar system and have been observed in ultraviolet and infrared wavelengths. Jupiter's internal structure is not directly observable, but scientists have inferred its composition and characteristics based on models and data from spacecraft like Juno. Jupiter is thought to have a dense core composed of heavier elements, with an estimated mass of 10 to 15 times that of Earth. However, the core's exact size and composition remain uncertain. Some models suggest that the core may have eroded over time and mixed with the surrounding layers. Surrounding the core is a layer of metallic hydrogen, which exists under pressures exceeding 3 million bars and temperatures of thousands of degrees Celsius. In this state, hydrogen behaves like a metal, conducting electricity and generating Jupiter's magnetic field. Above the metallic hydrogen layer is a region of molecular hydrogen, which transitions gradually into the atmosphere. This layer is composed of hydrogen gas and helium, with traces of other elements.
Jupiter's upper atmosphere has an average temperature of about minus 145 degrees Celsius minus 234 degrees Fahrenheit, but its interior is much hotter. The core temperature is estimated to be around 20,000 degrees Celsius 36,000 degrees Fahrenheit. Jupiter emits more heat than it receives from the Sun, a phenomenon attributed to residual heat from its formation and ongoing contraction of the planet's interior. This heat drives much of the planet's atmospheric activity. Jupiter has a faint ring system composed primarily of dust particles. The main ring is relatively thin and flat, while the halo ring is thicker and more diffuse. These rings are thought to be formed from material ejected by impacts on Jupiter's small inner moons. Jupiter has the fastest rotation rate of any planet in the solar system, completing one rotation in just under 10 hours. This rapid rotation contributes to its oblate shape and drives the strong winds and jet streams in its atmosphere. Jupiter takes approximately 11.86 Earth years to complete one orbit around the Sun, traveling at an average distance of 778 million kilometers, 484 million miles. Jupiter's physical characteristics are closely linked to its extensive system of moons. The planet has 95 confirmed moons, with the four largest, Io, Europa, Ganymede, and Callisto, known as the Galilean moons. These moons interact with Jupiter's magnetosphere and contribute to its dynamic environment. Io is the most volcanically active body in the solar system. Its volcanic eruptions release material into Jupiter's magnetosphere, contributing to the planet's radiation belts and auroras.
Europa is of particular interest due to its subsurface ocean, which lies beneath an icy crust. This ocean is a potential site for extraterrestrial life. Ganymede is the largest moon in the solar system and the only moon known to have its own magnetic field. Callisto is heavily cratered and geologically inactive, but its subsurface ocean may also harbor conditions suitable for life. Jupiter's immense size, complex atmosphere, powerful magnetosphere, and dynamic interactions with its moons make it a planet of unparalleled interest. Its physical characteristics not only reveal the processes that govern gas giants, but also provide insights into the formation and evolution of the solar system. Ongoing exploration by spacecraft like Juno continues to deepen our understanding of this fascinating world.